Okay. Okay. It's almost 10 and only say very few participants have joined yet. It's 10 past 1, right? And now only 62 entries are seen here. Hmm. Hmm. Let us wait for another 1 or 2 minutes and then we'll start. हा नीतू यांनी गुड मॉर्निंग सुप्रभात. वाढदिवसाच्या खूप 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 अनंत शुभेच्छा. हा, सकाळ काही नाही. सकाळ सकाळी म्हटलं एकदा फोन करून घेतला म्हणजे वाढदिवस निमित्त. आज काय विशेष प्रोग्राम आहे? नेहमी रुटीन की काही वेगळं आहे? अच्छा अच्छा, रुटीनच आहे. अच्छा, बरं. हो, संध्याकाळी येऊन बुवा, बाबा तुम्हाला भेटायला यायलाच पाहिजे वहिनी. हो हो हो. भेटूया, ठीक आहे. आमचे भाऊ उठले की नाही? उठले आहे, बरं बरं, ठीक आहे. अच्छा, ओके, तो हा. अच्छा अच्छा, बरं, ठीक आहे. चला, एन्जॉय द डे. हा, तुम्हाला परत वाढदिवसाच्या शुभेच्छा. ओके. मी कॉलेजमध्ये आलो आहे. सुप्रियाला मी तिला म्हटलं जॉईन नको करू इतक्या लवकर. ती हट्ट करता आजच जॉईन कर. म्हटलं एकटं घेऊन जॉईन कर तू. नाही, मला मला नाही पटत आहे बाबा वहिनी. मी स्वतः सांगतो, मला असं वाटतं त्यांनी जॉब सोडावा आता. म्हणजे मी कंटाळलो बा. म्हणजे मी म्हणजे आता तुम्हाला म्हणजे बोलायचं म्हणून सांगतो मी. मला असं वाटतं तर नको ते. म्हणजे त्या जॉबला प्रेस्टिज नाही उरलं, काही नाही, काय काही पेमेंटही नाही, त्याच्यात समाधान नाही. कशाला ती जॉब करते मला? मग असं असं वाटायला लागलं माझीच चूक. मला वाटतं माझीच चूक झाली. मी उगीच तिला नाही का एमटेक वर करवलं. एखादी साधी बायको केली असती ना, म्हणजे बिना शिकलेली किंवा असं कसं चाललं असतं वाटायला लागलं आता मला. खूपच म्हणजे म्हणजे मी फेडअप झालो बा, माहित नाही आता. हं. हो. नाही तसं नाही, पण ती ती हां. नाही, नाही, ठीक आहे. मी ते नाही म्हटलं. मी म्हटलं तिला, की 2 दिवस लेट जॉइन कर ना तू. एक तारखेहून जॉइन कर. असं म्हटलं आता माहिती आहे. तिचं थोडं सायकॉलॉजिकल थोडंसं नाही का, मी बघितलं आज सकाळी परत ती म्हणजे रडवी लिहून गेली. ती भीती वाटते कशी तरी सगळं ठीक होईल ना आपलं, असं तसं असं काही म्हणत होती ती. माहिती नाही म्हणजे तिला तो असं एकटेपणा किंवा काही वाटत असेल. एखादी पाहतो वेळ मिळाला एखादी बोलू आपण त्याच्या विषयावर. कसा वेळ मिळतो तसा? हो, 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 हो. हां, हां. नाही असं एकटं थोडं काउन्सिलिंग केल्यासारखं एकदा बघाच या मनात काय सुरू आहे मला असं वाटतं माहिती आहे म्हणजे. एक तर ती कशी म्हणजे हो हो मला माहिती आहे म्हणा. हो हो हो. बोलणं चालू असेल माहिती आहे हे तब्येती मी मला माहिती आहे बोलणं होत आहे तुमचं. हो हो हो. हा हा. हम्म, 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 हम्म. नाही इतक्यात आता मागे कोरोनामध्ये एक टेस्ट केली होती ते भरपूर ते 10-15 रिपोर्ट आहे तो पण मला केला होता त्यातही एक कळलं असेल B12 वगैरे सगळंच असलं पाहिजे यामध्ये असं वाटतं मला. मी पाठवतो हा मी पाठवतो हा. हो हो हो. Okay, see, I'm sorry, my audio was left open. Anyway, chalo, we'll continue for our discussion on the topic. So today we'll start for the discussion on the standards, right? The standards for measurement. Let us see the measurement process. Okay, so from this measurement process point of view, if you recall the earlier discussion that we made, into this, what it had happened, we have quantified something. Say, I have given an example of say measurement of some piece of land by means of some entity like say feet, right? So uh, the distance that can be measured by into the feet, say distance of the hand in earlier days it was there, so it was some kind of physical uh, it was something kind of physical attribute that we have given to the measurement of the length, say measurement of some field or some kind of thing like that, right? So we must have some kind of element with which we can refer the measurement that we can call as a standard, right? So the standard is required, and now as far as the engineering practice is concerned, now we are thinking in front of in the view of mechanical entity measurements, we must have some kind of standards, right? So the standards are required for having some kind of say relative measurement entity. So those measurement standards are nothing but they are some physical representation. Just now we have talked about a physical representation of the unit of measurement. So we have just now taken example. Say for example, piece of land is here, and then we measure that this land measures 10 hand distance on the length side, 10 hand on the say width of this particular piece of land. So then what happened? Say the measurement of the say distance of hand, say for a particular person may be varying from person to person, and then there would be variation in the length. So this very crude example that I am giving from the old Stone Age era or something like that. So this measurement is to vary. But if suppose something is required to be well accepted, right? Something is required for as a say well accepted unit, it must have some uniqueness. It should not differ. Right? So this is known or this is required for the accuracy in the measurement. So the accurate measurement is required. in terms of engineering entities, we must have some accurate entities. So the accuracy of the measurement. So for this, we must say agree upon some distance of this length. Say for example, some piece of say some metal. Say for example, the iron rod or some wooden rod or something like that. Right? So the unit of measurement is generally chosen such that it is going to be accepted over the particular community. Say for example, in the engineering community, we must have something that is acceptable for the particular way. The community must agree upon that yes, the length of the particular piece of land is this much unit. Say for example, this much distance of the hand, or this much times the distance of that piece of metal or something. So earlier, that's what I'm talking about. Earlier, the standards were arbitrary material standards. So it was not having a common agreement. Say in some place of a say tropical region, there were some different units for measurement. Somewhere it was used by means of the length of the hand, say length between the 2 points on the hand by some person. At some places it was used to be measured like the depth of the, say for example, earlier days we used to dig the well. So while digging the well, we used to say find out that the depth of the well is say 10%, the 10% deep, right? So it was arbitrarily. There was some material standard. It was arbitrary. It was having no common agreement. But now all the fundamental measurements are based on the universal constant. Now this most important technical word. Now we come to the technical measurement. It's a universal constant, like such that the time that is required to travel the light ray from one point to the other, that is going to remain more or less, or say almost fixed everywhere wherever you go, right? So it is nothing but like the sorry the speed of the light, then Planck's constant, etc. Standards are used to determine the values of other physical quantities by comparison method. All standards are preserved at a place that is called the International Bureau of Weights and Measures at some location, international location. So based on this understanding, now we can see here, there can be very broad classification of the standards or categories of the standard. There can be international standard, there can be primary standard, secondary standard, and working standard. Let us understand what is the meaning of this. Say international standard, just now we talked about in the earlier slide that we have got this, the standards which are preserved at International Bureau of Weights and Measures, say at Paris. Now all the standards which are available for a comparison at a particular group of scientific say community, then that may be called as the international standards, which are very accurately used for only referring for some national standards. Say for example, the standards that are placed as per the Indian tropical region concern, it is in somewhere say at Delhi, let us assume. So then if some comparison is to be done, whether there is any deviation or something like that, so that is to be made with the international standard, right? So international standard is defined first of all by means of international agreement. There is a document, a proper document that is made out, so that these many representatives of the community over the world or throughout the world are agreeing upon the kind of the measurement or the standard at international level. So that is through international agreement that comes in force, and all the members who are attending or the taking part in discussion are going to sign on that document. So that is what something we call as a document in a normal way. So it is an agreement that has occurred at international level between the different representatives, which say represent the closest possible accuracy that is attainable by the current science and technology. Say for example, the technique of measuring the time, that is the time required for traveling of the ray from one point to the other, something. See, this is measured on the technique, particular technique of measuring the time taken for light ray to take one point to the other point travel, the distance between that we call as a time measurement. If suppose now there is some new technology, some new method, some new approach has taken place for measurement of the time, then that will supersede. So depending on the current science and technology, we are going to attain the accuracy. Whatever is the most known possible accuracy, we are going to find out the one for the particular standard measurement, right? So the primary standard is the next one, which is maintained at the national level. Say for example, a tropical region and the national capital, let us assume, is going to have this standard. It is replication of the international standard, definitely. So it is maintained at the national, say at one place in a particular country, and it is a particular laboratory in which it is kept, which is varying for, say, which is respectively in their own country. So this is the one that is replication of the international standard exactly, right? So the function is to calibrate and verification of the secondary standard. The standards, those are used in the particular region of the country. Say that there are 10 or 12 regions or 15 regions into the country. See, in all the regions, we are going to have some standards, the secondary standards, which are compared with the primary standard. What is the use of the international standard? International standard is nothing but is used for comparing and calibrating the primary standard, or say estimating the accuracy of the primary standard is based on the international standard, whereas the next standard to this, the secondary standard, which is compared from primary standard, and the accuracy of this is established, right? So fundamental and the varied quantities are calibrated independently by absolute measurement. Say there can be different techniques of comparing the standard and the one that is to be used further for reference, right? So coming to the next secondary standard. Now if I'm going to put this in terms of the block diagram, say it is an international standard, then it will become the primary standard, I'm abbreviating this, then it will be the secondary standard. Through the exact method of measurement of the given entity, we are going to establish that on the international agreement here in the international standard, primary standards are compared with the international standard and it is established with given accuracy here. Similarly, secondary standards are placed inside the region of the country, maybe 10, 12 or some n number of divisions may be there. So those are having secondary standard. Each secondary standard placed in a proper laboratory is compared with the primary standard, and again accuracy of this is maintained. So secondary standard is maintained at the industrial measurement laboratories. There can be different names and tags for these measurement laboratories, but basically this is kept in the particular location of the region in a country. So used to check and calibrate the lab standard. Now next, it is the working standard or lab standard. So working standards are those which are used for the day-to-day say application of the say measurement. So here we compare that with the secondary standard, right? So it is used for checking and configuring the efficiency or they say accuracy of the working standards. It is periodically calibrated from the primary standard. That is what is very clearly say it's obvious now. And working standard is one that is used by the workers. It's actually the shop floor measurement. So for example, the instrument that I have with me, so for example, the steel rule or vernier caliper that is there into the laboratory, that are used into the shop floor, that are used by the industry operators, the different machinists and so on. So these are the workers, and the technicians, those are using those for their own day-to-day use, right? So the standards are used by the workers and the technician, commercially available as a high accuracy device. Now here it differs. It can be a high accurate device, it can be medium accuracy, and it can be very low accuracy, like that. So depending on the type of the application, we decide which kind of element is to be selected. So for calibration of the general laboratory instruments, we are using the working standards, or directly we are using that for measuring the workpiece. So it is, say, compared against the primary or the secondary standard. So then it can be either compared with the secondary standard, mostly with the secondary standard, but it can be sometimes compared with the primary standard also, which are placed at some national laboratory, right? So now I think we are well known with the length, mass, time, electric current, temperature, amount of substance, and luminous intensity are the very basic entities that are calibrated as per the international agreement, and their unit particularly is meter, abbreviated as M, kilogram, second, ampere, Kelvin, mole, candela. I think this is all known to us, so I needed to stress upon this much. Now apart from this, what happens, many times there are some entities we measured which are combination of some, say, 2, 3 or more number of fundamental entities. Then that will be called as a derived. Say there is a, say, primary or say standard units of the measurement, and there are some derived units. Say derived units are nothing but combination of multiple elements. Say measurement unit 1, measurement unit 2, measurement unit 3 will have some relation, and the entity that is under measurement, say, is a function of different units here. So this is a final entity. Let us call this W as a final entity to measurement, to be measured, is function of different values here. Function of FU, so U1, U2, U3, and so on. There will be some relation, multiplication, division, and so on. So take example of force, pressure, force. What is the unit of force? Is nothing but mass into acceleration. Pressure is nothing but the force per unit area. So this is what is the proportionality here. Say multiplication. Say here will be multiplication. Then if it is the pressure, pressure will be equals to the force upon area. So this is division. Stress, energy, power, electric charge, potential difference, capacitance, electric resistance, flux, magnetic flux density, so on. These are the entities having some dependency on different units, fundamental units of measurement, right? So we call that as an international standard, derived international standard. Area, for mechanical entities, we can find area, acceleration, angular acceleration, velocities, density, dynamic viscosity, heat flux, moment of force. Moment of force, that is nothing but the moment, the force into the distance we call. Then specific heat, capacity, velocities, so on, are the derived quantities as far as our mechanical engineering concerned. I think it's very clear and say very simple to know. There is nothing new into it. I am just recalling something that we understood from some other places. And this is taken from the table. This is taken from the book of Doblin. From the book of P.O. Doblin, you can use any of the measurement textbook for knowing. Say, for example, area. It is expressed as square unit, meter square, and so on. So all these entities you can find out. Volume, velocity, acceleration, angular velocity, density, specific volume, mass flow rate, volume flow rate, force, pressure, torque, momentum, moment of inertia, kinetic viscosity, dynamic viscosity. I'm just reading this. Work, energy, heat, specific heat, power, conductivity, charge, EMF, potential difference, field strength, resistance, capacitance, inductance, conductance, so on. Right. So these are the symbols. And then these are the derived equations or derived formulas for this. Now this is something that we must know. I think we have already gone through. We are recollecting this for the understanding of mechanical measurement as such. So international standard, let us say kilogram. I am not going in much details of this. Kilogram, mass of 1 cubic decimeter of water at 4 degrees Celsius. It is material representation as an international prototype of kilogram. which is preserved at Paris, laboratory at Paris. The mass of a platinum iridium cylinder that is kept into the International Bureau of Weights measures Paris. Right. So from 19, now it is changed with some relation based on the Planck's constant. Right. This is for kilogram. Then same is the length. 1960 length 1 meter was the distance between the graduation on the bar, platinum iridium bar of given diameter from one point to the other. The graduation made was equivalent to 1 meter, which is kept at very standard temperature and pressure. Then also it was equated 1 upon say 10 to power say 8 is the distance between the equator of the North Pole passing through the Paris. After 16, it was wavelength of krypton organ red light. After 83, strength of the path traveled by light, the length of the path traveled by the light in an interval of this much seconds in vacuum. It was said it is based on the latest technology that is used for accurate measurement between the two different points on a particular element. So time second is nothing but of a 1 upon this much time of a mean solar day. I think you are aware of this. I need not to describe this again. Just to recollect how the length standard has changed over the time and what that we are using as on date. What is the measurement of time and how that is correlated as on date using the latest technology. There is frequency of the sesame transition between the two hyperfine status of say that is in correlated to some hertz. I think I will skip this part directly. Then it is seismium clock, temperature Kelvin, you know it, current ampere. So Lewis intensity candela, meter, sorry, the mole, the total content of the substance. Now, from 20th May, the kilogram will be defined with the Planck constant, that the ampere will be defined by the elementary electric charge, the Kelvin will be defined by Boltzmann constant, the mole will be defined by Avogadro constants. Now let us come to this is more important. Earlier to this slide, it was just recalculation of the different terms. Now we must know what is calibration. Again, you go back to the process of measuring some piece of land and say now we have used some distance on some metal bar or some wooden piece, something as I say standard unit. We must be assured how accurate the unit of measurement is. Now process of getting assurance about the distance between the 2 points on the bar or on the wooden plank, we call that as something calibration. So it refers to a situation or the process or the steps or the task in which the inputs except the one that is under measurement is kept constant. So for example, now I want to know how much is the length of this piece as compared to the standard, say maybe local standard I'm using. So what I'm going to do is I'm going to find out the distance between the 2 points, and then the unit that I have measured, I will take the standard scale and compare this. Now what is done? Except the length which is under measurement, all other inputs are kept constant. Say for example, temperature, pressure, and all the entity that is available in this room, they are kept unaltered, so that only variation in the displayed output of the measurement system will be say checked. So it refers to situation in which all the inputs, though this is a very simple case of measuring the distance of the particular element like this, say refill and the distance I am measuring, say it is say what something 1.5 times or like that. Very crude method of measurement. It's very simple because there is only one entity. But in mechanical processes, you will find there are multiple factors influencing the measurement and the accuracy of the measurement. So for this, right, we must know that only the element under measurement is kept constant. then the input under the study is varied over some range of the constant value, which causes output to vary over some range of the constant values. Right. So again, coming to the early example. So with respect to this element, the measurement is carried out, and here suppose now I am going to calibrate the stick that is used for measurement here. Then this is compared with the standard scale, the steel rule, a very highly accurate or say calibrated steel rule. And then I take multiple measurement. I find out, say first time it is going to show something as 10.025. For example, the length that somebody has measured, say arbitrary value we are taking 205 millimeters, length of this pencil with respect to the standard component that I am comparing. The next reading that I am going to get is 10.215. Somebody, the next reading has given 10.230. The various elements that we are taken. So what is happening? The output is going to vary over the same range for the same standard input. We are going to find what is the deviation shown in the output. And then we find the difference between the standard input. Now we know that it should be equal to something as a 10 centimeter or 10 millimeter. But actually it has shown some values. So there are different mathematical methods now, the approaches. Someone can have average of this, and then this average, suppose it comes around 10.205, suppose the average of 1000 reading that you are taking for the same entity. Then you can say that the inaccuracy or say the difference here is something with say 10.205 minus 10, which is a standard input. Right. So this is what is said here. Then the input under the study is varied over some range of constant values. If it is single entity, then it will not be varied, but it will be measured multiple times. If say it is a pressure measurement, say in the pressure measurement we know it as per the basic rule, it is force upon unit area. So I must have the area as a constant and force as a variable. So then I will get different value of the pressure for different forces. And then we'll see the input is varied here and output also is varied. And then we have seen how it is going to vary. We want to establish the accuracy between them. The input-output relationship is a static calibration. So this is what is called a static calibration, which is valid under the stated constant condition for all other inputs. Right. So I think we are going to study about this. We, as a student of measurement, we must know how the calibration is carried out for any instrument that is given for measuring the mechanical entities to us. So for example, temperature measurement devices, that those devices we handle through laboratory, that we handle in the place of actual measurement on the shop floor for temperature measurement, for example here. We must know how the calibration of particular entities is done. So this method describes the ideal situation. All other inputs are measured independently. Say for example, the process. You go to this new value, say calculation of the area or calculation of say let us say power. We know that there are different equations, different terms involved into the equation of power. So all those the measurements, say power is equals to twice pi nt upon 60. This is the equation. Then I have pi n t. These are the entities under measurement. So where is pi is a constant, n is the speed in rpm, and say t is the torque. Then we go on measuring these entities, the different entities which are responsible for torque. Now, so for example, torque is nothing but function of force as well as the distance on which the force is applied. Right. So we calculate, then we measure force accurately, we measure the distance accurately, and so on. So that is what it says. Method describes the ideal situation where all other inputs are measured independently. Instrument to measure other inputs need not to vary. Okay, Abhishek, what is the time to enter into the class? It is 10:35 now. Only 10 minutes are left for finishing the class. Say from next class onward, it should not happen. We should not allow any one of you to enter the class after 5 minutes or say something. Please be aware. For that only I have asked what is the time the earlier class was left. So it was well 3 minutes before the time of start of this class. So please be careful now. Onwards, I may not allow you after 5 minutes. Please try to come in time. It's not matter of entering the class late. It shows your sincerity to at least see something on the screen, or at least log in to the system. The worst case. Now, Abhishek, you please be aware of this one. So all of you also need to take a note that try to join in the given time. Otherwise, you will not be allowed to enter into the classes. Okay, coming to the next. So during calibration, input should be accurate. Say, because it is going to have the question on the accuracy of the measurement. So we try to eliminate the ways through which inaccuracy will be brought into the system. As far as possible, as per our knowledge and belief, we try to have the input being measured most accurately. Accuracy of the input device shall be said, this is very broad way of looking at a thumb rule, we can say, for selecting the measuring instrument. So for example, now I want that my job, say piece on the turning machine or the lathe machine that I am going to make. So for example, this is the job I am going to make, and the distance that I am going to measure is suppose here 25.001. Say 25.01010, let us say. Now the device that I am going to use for this measurement must be better in accuracy than the second decimal. Then if it is accurate to the third decimal, accuracy of the vernier caliper, suppose, or micrometer, if it is of the order of 0.001, then only it is capable of measuring this deviation. So with this very obvious understanding, we have got a thumb rule that accuracy of the input should be at 10 times better than the actual measurement or the instrument that is to be calibrated. This from measurement point of view, I told you that the job of 25.01 is to be measured. I must have a vernier caliper or micrometer screw gauge which is better accurate than these 2 decimal points. So it is desired that it should have accuracy up to third decimal. Same thing is applied here. The element, suppose this is now the element under calibration, this is steel rule. Suppose I have a steel rule with me and I desire that the accuracy of the steel rule is up to 2 decimal. Then definitely the instrument that is used for checking this steel rule should be better accurate, minimum 10 times accurate than the steel rule that is being calibrated. It's very obvious now. So for calibration, standard input is given, or input which is compared with the standard is given. The way of having the primary calibration is the calibration against the primary standard is done, whereas for secondary standard, working standards are calibrated against the primary standard. This is what we were discussing in earlier slide. So secondary calibration is calibration against the secondary standard. I think this is some routine method of having comparison. Calibration against working standard for routine calibration. Say for example, the steel rule that I am going to use in the fitting shop, in our workshop, that will be calibrated with the working standard that is kept somewhere in the workshop itself at some condition in a preserved way. Okay, so calibration of the shop or laboratory equipment or instrument is to be done with something that is preserved at a good place in a controlled temperature, pressure, and other conditions, which is to be done periodically, right? So there are now methods called as a direct calibration. Obviously, there will be one more called as the indirect calibration, right? So the direct calibration is one with the known input sources. Say for example, flow meter. It is a flow meter to be calibrated. Then in the flow meter, what is there? The process is fundamentally governed by volume of the fluid or volume of the element flowing per given time. So volume and the time are the entities which are under measurement independently but simultaneously measured and then calibrated with the primary standard. So if it is a flow meter to be calibrated, we are going to measure volume and time independently with 2 different equipments or 2 different measuring systems. Simultaneously we are going to measure, and we are going to measure that with the primary standards available with us for measurement of time and measurement of elements in the volume measurement. So what is the volume? It is length into width into thickness, a normal way, or if it is a round element flow meter having the round pipe, there will be the diameter, so the volume and the length of the pipe length. So this may be the entities for volume measurement. So it will be, say, pi by 4 d square into L something for measurement of volume, and for measurement of time there will be one element. So we measure by means of diameter, and length we measure by means of the vernier caliper or screw gauge. So what we do, we measure these independently but simultaneously with whatever better accurate standards available with us, say primary standards available. Calibration with the devices having accuracy equivalent to the primary standard give similar accuracy. Calibrated device can act as a secondary standard. If the device, for example, flow meter is calibrated, that accuracy is established, that our flow meter is accurate to all the measurement up to say 0.1% of the given measurement. Then once it is clearly identified, then this device can be used for calibration instrument to other flow meters which are little less accurate than the given calibrated flow meter. Thus, it shows that once the device, a flow meter, is calibrated, it can be used as a secondary standard for calibration to other flow meters which are little inaccurate than the one being calibrated. Right. Now there is another method of indirect calibration. Into indirect calibration, the calibrating the equivalent device in place of the device which is calibrated. Say for example, now this is a phenomena. Say turbine flow meter which are geometrically similar. They have equal Reynolds number. So suppose this is the equation for giving Reynolds number of system 1 and system 2. Then once a system 1 is calibrated, we can use that for calibration of this, that is the indirect calibration. The earlier example we have taken, the calibrated device can be used as a secondary calibration. This is indirect calibration now. Indirect calibration of the flow meters used in house, say for example water measurement or something, that can be calibrated using the calibrated flow meter. So it is indirect calibration. Direct calibration and indirect calibration. So I think you have got the difference between the direct calibration. Direct calibration is in connection with the primary standards, something that I am calibrating using very established primary standards. That is called the direct calibration. Whereas indirect calibration is one. Suppose now this instrument is calibrated and I am using this instrument for measurement of this entity, something like that. So this is secondary because calibrated device is used for measurement of the actual components. That is a secondary calibration. Whereas direct calibration of this, I am going to calibrate this by steel rule or a very preserved physical device for measurement of length. That is a direct calibration. I think this difference is clear to you. Direct calibration involves use of a primary standard as a main calibrating device or the main device for comparison. Whereas in terms of the secondary or indirect calibration, we use calibrated device for knowing the accuracy of something else. Right. So it is possible to predict the performance of one device by studying the performance of equivalent device. So this is what is the basic understanding for the indirect calibration. Right. So I think this is what is the discussion on the calibration, primary standard and the secondary standard. You let me know any doubt in understanding this. Right. If there is some doubt, you let me know. Otherwise, we'll be able to move ahead. Only 5 minutes are left. I think we'll continue for the next slide. At least 1 or 2 slides can be seen. Now, there is one important announcement. I have already given some devices for your study. So those devices I think I already have declared that this week there will be test number 1. So test number 1 is the quiz. It will be of MCQ type. that we are going to conduct on the Saturday's class. Anyway, that we are not going to engage as a theory class, but that will be used for this kind of activities like the test and the quiz, class test, quiz, or some kind of assessment will carry out. So this Saturday, there will be test number 1, which will be basically confining to identification of the primary sensing element, secondary sense, the variable conversion element, and so on. And little next portion of this, say what are the signals available after each of the functional block that you need to identify. You should be in a position to sketch out the functional diagram. The example that we have seen, say for example, the I will show this one. Say if you recall the example of the thermometer, pressure thermometer. Into this thermometer, what you have seen, I am going to show very roughly the diagram here. So there is a pinion, and to this pinion pointer attached. Now this device, we have identified what is the primary sensing element, what is the variable conversion element, what is variable manipulation element, and so on. And we have shown also what are the signals available at each of the functional block. So then you should be in a position to identify what are the different functional blocks, then what are the signals available, and so on. And so you study the element given to you, the 12 figures that have been given to you, you study, and then we'll conduct the test. So before the test, say 5 minutes before the test, suppose it is to be conducted at the time, our class is from 12 to 12:55. So at 12 o'clock, if test is started, then we'll give the link 5 minutes before. You will have to open and you will have to solve that. Everybody will get different questions, and then you will have to submit that through the Google link. So similarly, test number 2 and 3 will be there in the next week. I think we need to conduct 2 tests there. So we'll try to little speed up because we have lost few of the classes anyway, and we'll try to finish up our portion of the dynamic characteristics. We'll try to catch up till the day of examination, and I think your exam is starting from 14th of February. Am I correct? Any answer from your side? What is that? 3rd March?
2nd March.
2nd March. Your first test is going to start from 2nd March.
Yes, sir.
Okay, first mid-sem. Okay, anyway. So till that point of time, we will try to finish up our portion. So if it is in March, then we have got little more space to breathe out. So I think I'll say stop presenting here. Let me see, can I start for the next part? Right, at least a single slide, at least we'll be able to take one slide at least. So I'll share that and we'll discuss. Right. So I think we are here for the errors in the measurement. Now this is a topic in continuation. Let us understand the process of calibration again. Into the calibration, what we have done, we have compared the system or the particular entity that is under measurement with some standard available with us, maybe the primary standard, secondary standard, and so on, tertiary standard, and so on. So into this, there can be different ways in which inaccuracy can enter into the measurement. So there are different types of the inaccuracies or types of the errors that can be incorporated into the system. So what is the error? From very normal logic of that we understood is a difference between the true input given and the measured value that is shown by the display of the measurement system, or that we have interpreted from the comparison. So for example, measurement of length by using scale or something, the measurement of voltage that I think you have shown the practicals that we are going to conduct. The instruments are showing some readout. So readout shown by the instrument and the input that we have given, the true input. The difference between that is nothing but the error. So there can be different types of the errors, say systematic or cumulative errors, Then there can be random errors or accidental errors that are occurring into the system, and there can be miscellaneous types of the errors. So there are three different elements: a systematic error, then random, and the miscellaneous errors. Now we try to understand what is systematic error. The name itself suggests that systematic or the cumulative error is one which is going to have the magnitude same and the sign same for a given set of conditions. Say for example, now what is the meaning of magnitude? The value that is being shown. There are, say, different error sources. Now let us assume that there are 2 or 3 different sources. Say source 1 of the systematic error, source 2 for the systematic error, source 3 for the systematic error, and so on. Now take an example, very simple example of measuring the distance using the standard steel rule. Now whatever sources that I have clubbed together as a source for systematic error will have same magnitude. Now in this case the magnitude will be in terms of millimeters. Say for example, source 1 is going to show difference of 0.01 millimeter. Source number 2 also will show some difference in terms of millimeters, maybe small, again say 0.001, let us say. Third source also will have the same magnitude, that is in millimeters, the deviation in millimeters, and then sign. It will be either plus or minus. It will either add something in the output or it will have some kind of subtraction, but it will have same magnitude and sign for the set of condition. For example, I am going to have upscale reading. All the scale reading will be always plus, shown by reading the source 1, shown by the source 2, shown by the source 3, and so on. It will have same sign and same magnitude. So all such errors tend to add because of the signs here, say plus, plus, or plus minus, or minus, minus, minus everywhere. It is going to have the cumulative effect. Now let us understand this. So at the end, the total systematic error given by the measurement system will be the algebraic sum of all the individual sources responsible for the cumulative errors, the systematic errors. Such errors alter the reading by the fixed magnitude. Say for example, again go back to the scale, measurement of the length by using scale. The different sources of systematic error are going to affect the last value that is shown as output or interpreted output. So for example, actual length of that component is 10 centimeter. Say for example, this is 10 centimeter. If I am applying scale here, it has shown something as say 10.1 millimeters. So this 0.1 is nothing but output of error because of source 1, error because of source 2, and error because of source I. For all the systematic errors, all the errors because of the systematic, the approach, the systematic pattern for source 1, source 2, source 3 is going to be a cumulative effect at the end. Any doubt in understanding what is the meaning of cumulative or systematic error? Please ask, because this is something to be understood. This is not the way that you are going to leave this as, because this can lead out to the questions into the vivas. Say for a given instrument, suppose, that is asked to you in viva, we will have to identify what are the systematic error sources or the cumulative error sources. Any other doubt here? What is the instrument bias? Bias is nothing but some increment shown as output on the display panel, or it has been given for interpretation by the observer. Here 0.1 will be always a bias. Suppose now there are 3 error sources, systematic error sources, and if it shows 0.1 millimeter as a deviation, possibly now if I am getting the other bar for length measurements of 5 millimeters, measurement of that could lead to 5.01 or say 5.1 millimeters, sorry. So this is 0.1 will remain constant for any entity that is given for measurement. For example, the smaller length or the larger length, true input will be added with this fraction which is going to remain constant. Say 0.1 only, say here 0.1 millimeter will be the addition, that is called as a bias. So whatever input you give, it will show something higher than 0.01 units. So we say that is a bias. Say something, say for example, I have got a very say attachment to something, and then I will always give some kind of say concession to somebody, then that is a bias. I think that is, we know this. Bias is nothing but something that we favor. So instruments are unintentionally favoring the measurement by this quantity of 0.1. That is called the instrument bias. Right. So I think now the time is over. I will stop here. We'll start discussing this from the particular slide here in the next class. Right. So I will stop here. Thank you for joining. Be aware now. I have already told you that there will be examination on this Saturday. Okay. So I will give some more detailed information regarding the test on some WhatsApp message. Right. Thank you for joining.